time to move on. Second hour and a half of maths for today. Introduction to quadratic equations. Quadratic equation is an equation where there's the highest power of an unknown quantity is 2. So it's a term where if we're talking about x, we've got an x, at least an x squared term in it. We also could have an x term. We could have a constant. Okay, if there's an x to the power 3 term or an x to the power 4 term, it isn't a quadratic anymore. It'd be a cubic or a fourth, whatever you call to the power 4. So, plotting a quadratic equation will produce a curve, and the name for that shape of curve is called a parabola. Quite common shape of curve if you're analysing kind of projectile situations, things flying through the air, that type of thing, and there are other areas as well, okay? And the curve can end up as an upside down parabola like a cable hanging, or it can be that way up. So they can be either way up, and as we adjust the coefficients in front of these variables, the shape of the graph opens out or closes up, it shifts up and down the y-axis, and it can turn upside down when the coefficient of the squared term is negative. So when we say we're going to solve a quadratic equation, what we mean is we're going to find the roots of that quadratic equation. And the roots are the value of x when the value of y is equal to 0. Okay? Now, actually all quadratic equations have 2 roots. Sometimes they're the same, sometimes they're 2 real numbers, and sometimes they're non-real numbers or complex numbers. So that top one has 2 real numbers as roots. So 2 values of x where y is equal to 0. Then you get a version where the parabola sits on the x-axis. Could be an upside down parabola like that, just touching the axis. You'd still say it's got 2 roots, but they are the same number, where x is equal to 1 or x is equal to 2 in both cases. 1 real root. And then we have one here where the whole parabola is sitting above the x-axis. We could have a whole parabola sitting below the x-axis and not crossing it. There are no real roots in that particular one. The roots are complex, and complex roots are beyond the scope of this course. Okay? This module. So we won't be dealing with trying to find the roots of that kind of quadratic equation. We'd be making an assumption. All we'd just say is there are no real roots for that equation because there aren't any. They're complex. Okay? So, we're going to cover 2 methods of solving quadratic equations. First, we're going to look at factorization. Then we're going to look at using the quadratic formula. So, solving by factorization. What I want you to do, I'm just going to stop the video for a couple of minutes, multiply out the brackets for 2x plus 1 in brackets multiplied by x minus 3 in brackets. Right, Jordan, what you got? 2x squared minus 6x plus x minus 3. And simplified, okay. So that's that expression with the brackets multiplied out, which is what I should have put, hopefully, underneath there. Yeah. Okay, so the process of going from that multiplied out term to the bracketed term is called factorization. So if we're going to use this method on a function in this form, ax squared plus bx plus c form, then it's the process we need to factorize from that to end up with two bracketed terms like this. If the equation is easily factorized into two brackets, then this can be the quickest way to find the roots. However, sometimes a factorization is not easy or is impossible, and in these cases we'll use the formula method. Okay, one thing about we'll be looking at an example where the formula method takes longer because of all the fiddling about trying to use the calculator in it, and that's actually quicker to factorize. But we'll look at an example where the factorization is possible but takes a long time, and the formula method is quicker. One thing is that if there are real roots, the formula method will always find them, as long as you use your calculator correctly. Okay? So, moving on to the next page, if 2x squared minus 5x minus 3 is equal to 0, so this is the same problem. This page is how factorization helps you to find the roots. Then we'll move on to how you actually factorize an expression to do a problem this way. So if we've got that, we've already said that we can factorize that into those two bracketed terms. Yeah? Now, if the product of two numbers, because that's all that is, 2x plus 1 is a number, and x minus 3 is a number, yeah? The only way the result of multiplying those two numbers together can be equal to 0 is if one of those two numbers itself is 0. You all kind of get that? So what we're saying is if we set x minus 3 to equal 0, then the result will be 0. So we got then 2x plus 1 is 0. So kind of done that here. I've said when 2x plus 1 equals 0, okay, we can say that 2x equals minus 1. We've added 1 to both sides to end up with 2x as subtracted 1 from both sides, sorry. We've done minus 1 on that from both sides. And then we've divided by 2 to end up with x is equal to minus a half. So that's one of the solutions, or one of the roots of that equation. And then when x minus 3 is equal to 0, we plus 3 on both sides, x is equal to 3. So the roots of this equation are x is minus a half or x is equal to 3. And when that neatly factorizes like that, that's a reasonably easy way of finding a solution. Okay, so what we've got to do if we want to use the factorization method is end up with two bracketed terms involving a variable multiplied by each other, and then we imagine when they're equal to 0, what's the value of x. We set each of them equal to 0, rearrange them to solve for 2 and find the 2 values of x. Well, there might only be one value of x if there's only one. If that's a parabola sitting on the line, there'll only be one. Okay. So let's have a look and see how we can do this factorization. We've got a x squared plus 2x minus 8 equals nothing. If we're going to factorize that, we've got to come up with a term in 2 brackets. What do I need to do in the 2 brackets to end up, when I multiply them out, with an x squared term? I need x there and x there. They would multiply out to 2x. Okay. Now, in here and here, there and there, what I need are 2 numbers that multiply to make minus 8, because when I do that value, let's call them A and B, right? When A and B are multiplied together, they've got to make minus 8, and when they're added together, they've got to make 2. So what options have we got multiplying 2 numbers to make minus 8? Minus 2 and 4, minus 4 and 2. They're the only ones that... Minus 4, you can have minus 1 and 8, or 8 and minus 1. All of those options will multiply to equal minus 8, won't they? But only one of them will add together minus 8 and minus 8 and plus 1, yeah. Only one of those 4 options will add together to make the 2 in the middle. Which is it? Minus 2 and 4. So we've got to put minus 2 in one side and plus 4 in the other. And let's just multiply those out and make sure. X times x is x squared. X times 4 is plus 4x. Minus 2 times x is minus 2x. And minus 2 times 4 is minus 8. And these 2 come together to make x squared plus 2x minus 8. Yep. So that's factorising. So we've factorised this problem. What we can now do is how do we find the 2 roots? Yeah. When x minus 2 equals 0, x equals 2. When x plus 4 equals 0, x equals minus 4. So those 2 are your 2 roots for that equation. You all follow that problem? The key to it has been able to factorise the expression. B 3x squared minus 11x minus 4 equals nothing. What's the best stab at factorising that? What can we do to end up with 3x squared? 3. We can't have anything. 3x in one side and x in the other side. Okay. Now we've got to have two numbers that multiply together to make minus 4. So what are our options? Options for minus 4 are two numbers that multiply together to make minus 4. Minus 2 and minus 2 times minus 2 is plus 4, yeah? So it's minus 2 and 2. Minus 4 plus 1 plus 4 and minus 1. Okay, so we've got three options that will make the minus 4. And here we've got to make a minus 11. With one of those numbers being multiplied by also by 3 as well as x. How can we make minus 11? With 4 and minus 1. And we need the minus 4 and 1. Where do I put the minus 4? So that's going to be multiplied by 3 to make minus 12. And then we've got a plus 1 on that side. We'll bring it back to minus 11. Well done. Okay. You could check that by multiplying out the brackets if you're unsure. Okay. But we can go when 3x plus 1 equals 0. Three x equals minus 1, x equals minus a third. And when x minus 4 is equal to 0, x equals 4. Agreed? You could easily check that by plugging the numbers into the original function and making sure they worked. No, well, depends on the problem, Lewis, because the answer to simple the roots of that equation are that x is minus 3, minus the third, sorry, and x is 4. But in some problems, you might not be interested in the negative value. Depends what problem you're trying to solve. There are problems around the width of a path around a rectangle here, where you're trying to find the width of that path, and that involves a quadratic problem. You're not interested in any negative value because a negative width don't make sense in that case, or a negative volume if you're looking at the volume of a tank. Yeah, so you'd ignore any negative roots. The one you're interested in is the positive one, but it just depends on the problem. All right. When we're looking at a basic equation and we aren't in any kind of application, then the correct answer is both answers. All right. So, moving on from that, solving quadratic equations using the formula. The more times you write this formula, the more likely you are to remember it. Okay? But for a quadratic equation in the form of ax squared plus bx plus c. That's the standard form. And if you're given it in some other form, you can easily multiply out the brackets and rearrange it into that form. You can find the roots using the quadratic formula, with the answer being that x is minus b plus or minus the square root of all of b squared minus 4ac over 2a. Okay, so for simple problems where they easily factorise, the formula method's a bit unwieldy because there's a lot of plugging in the calculators to do, and there's a possibility of errors with negative signs and that kind of thing. Okay, but using that problem, or using the formula on the same problem as we just looked at, I think that's the same problem. No, is it on 2x squared minus 5x minus 3? I think that's the initial problem we had a look at. Okay, what we do is we just plug the numbers in the formula. So I've got minus 5 in there for b, and note how I've used brackets liberally. I've put the minus 5 value of b in a bracket because it's minus, effectively minus 1 times 5. So down here, that becomes a positive 5, plus or minus. And then in here, I've bracketed the term minus 5 before I've squared it. Important to do that in your calculator. If you do minus 5 and square it, what your calculator will do is 5 times 5 is 25, and then multiply it by minus 1. Doesn't come up with the correct answer. Comes up with the answer minus 25, when the actual answer is 25. Okay, so just watch that one. And then I've put in, all in brackets here, the value of the constant 4, the value of the coefficient of x squared, which is a, there is 2, and c is minus 3. And then 2 times the value of a, again underneath. Then got rid of some of those terms, made them into neat numbers. In the end up with a constant plus or minus the square root of another constant divided by another constant, and then just do that calculation twice, because there's 5 plus to give one answer, x is equal to 3, and 5 minus the root of that over 4 to give the other answer, minus a half. They should be the same results as we got for that equation when we used the factorizing method. I think that was the one we done, very first one. Be that one. X is minus a half. Well, it ain't more exact. Let's come up with the same solution, Dom. Yeah? But when you get a more complex quadratic, you won't be able to factorize easily. There's the factorization method. Okay, we come up with... On which one? Oh, after the one with... Yes. So when your coefficients are more tricky, that's when the formula becomes essential, because you can't easily do the factorization. All right. So that's the formula method. So have a go at those two. X squared plus 2x minus 8 equals 0, and 3x squared minus 11x minus 4 equals 0. Do both of them using the quadratic formula. Write it out how I did. Use the brackets how I did. Simplify it and come up with 2 solutions for each of them. With a problem like this, it was possible to factorize it, okay, but there are not only options, 4 different options to end up with minus 3. that there were two different options to end up with the 6x squared in the first place, that then need to combine with one of those four options to find the right method for factorization. That took, was it 4 goes to get the right pair, right combination? So the moral of the story is, because how long would it take to do that with a formula? Wouldn't take Caleb very long, that's for sure. Right, but under pressure in the exam, what would you do? Formula, yeah. Because you know that it's going to work, okay? You're not sure if you can find quickly the right factorization. So unless that's there right in front of you, and I would say maybe you'd try factorization if the squared term has got no coefficient in front of it, if it's just x squared on its own. Because then you haven't got this problem of there being a coefficient with one of these two terms. So if you've just got x squared on its own, then you might have a go at factorization. But if you haven't, if there's a 3x squared or 2x squared, probably go for the formula. Okay, certainly if you've got fractions or you've got decimal numbers, formula. Don't even think about trying to factorize, formula. Okay? So although we've shown that method, only use it if it's going to be the quicker method and you're confident with it. Okay?
Will the formula be on the exam paper on the back?
Yes, that formula will be there. Yeah. I see no reason why, as engineers, you should remember that formula under pressure in an exam. All right? So, what we've got is a problem. Calculate the diameter of a solid cylinder that has a height of 82 centimetres and a total surface area of 2 meters squared. This is more of a kind of real-world problem involving a quadratic formula. We've been given the area. I is 2 meters squared. We've been given the height, let's call it h, 82 centimeters. And then we're being asked to find the diameter. Which we might do actually by finding the radius. One thing's flagging up to me, there's a danger already in this question. What is it? Different units. Well spotted, Paul. We've got an area in meters squared, but we were given a height in centimeters. So what would we be best to do with that height in centimeters? Make it a height in meters, which involves moving the decimal point to make it 0.82 meters. So just watch for that, because that's like a little trick for an exam question, is give you different levels of multiples of unit to see if you're awake. You might also do 82 times 10 to the minus 2, but I'd do it this way if that was me. Okay, so we've extracted the information, the key information from that question. How do we move forward? Sometimes a diagram will help. Here's our cylinder. We don't know what that is. That's what we're being asked to find. We know that the area, cross-sectional area, or the surface area of that cylinder, is 2 meters squared. So, the area of that bit, plus the area of all this round here, is equal to 2 meters squared. So can we write a formula for the area for this solid? A equals, okay, you're saying the area of the ends, yeah, plus area of curve surface. Now, can we write an expression for the area of the ends? Two pi r squared, the area of a circle. We've got two ends. Yep. Plus, how can we write an expression? We need it in terms of r. So here we're going to find the radius and double it to find the diameter. What's an expression for the area of the curved surface? 2 pi r, that's the circumference. 2 pi times the radius is the circumference, and times it by the height. Yeah, exactly. Yes, that's the expression for the area. Okay. So what we've got is 2 is equal to 2 pi r squared plus 2 pi r h. We can put the numbers in for h as well, can't we? Height is 0.82. What we really need to do now is get that into the form where we've got it equal to 0. That'll be in that standard form. So if we add 2, subtract 2 from both sides, we'll end up with 2 pi r squared plus 2 times 0.82 r minus 2 is equal to 0. Does anybody not follow what's been done there?
Where's your
It's disappeared. Someone ate it. What's 2 times 0.82? Right, so if this is in the form of ax squared plus bx plus c, what's the value of A in this case. 2 pi. B equals 1.64 pi. And C equals minus 2. Now use the formula to find the radius and hence the diameter of that cylinder. Radius equals, go on, tell me what you got.
0.239. Round that up.
Anyone agree with that?
I got 0.88.
Yep. Who's right then? There is another solution, because there's 2 minus 1.107.
I got minus 0.992.
The units of those, of course, are meters. Yeah. We would need to double them. So which are right? We're looking at using the formula method. Minus b plus or minus square root of b squared plus 4ac all over 2a. Plugging the numbers into that, we've got minus 1.64 pi plus or minus the square root of 1.64 pi all squared plus 4, hang on, it's minus. I even got the formula wrong myself now, it's minus 4ac, isn't it? Minus 4 times A 2 pi times C minus 2. And all that lot is over 2 times A, which is 2 pi. So is that what you got, Paul?
Yeah. Didn't put the 1.64 pi squared.
Yeah, so you get that. That's the danger bit, because that's you got to square all of that. Yeah. Yeah. Because that's the number. You've got to square all of that. Yeah.
Yeah.
So that's where you're probably gone wrong, because the answer is x is either equal to minus 1.107 or x is equal to plus 0.287. So 3 significant figures. In this case, we ignore the negative value because a negative radius to a cylinder is nonsense. Okay, so the diameter equals 2 times 0.287 equals 0.575 meters to 3 significant figures.
I got 4.56. Yeah.
And,
Yeah,
did you have it written out in full like mine is, Lewis? Yeah. So, and you got what?
Put the wrong number somewhere.
Yeah, probably. Okay. Now, you might actually get a question similar to that in the exam as one of the problem style questions. Okay? So, it's an issue where the formula is definitely required. Factorization. You wouldn't want to be tackling factorization for that problem. Okay? Now, in your notes, I've got what I want to do is as two further pages in your version of the notes with some further problems to have a go at on simultaneous equations and on quadratics. Okay? And next week, boys, next week we're going to have a look at these topics. Trigonometry, wave functions, angles in radians and degrees, right angle triangles, and the sine and cosine rules. So, rest of the session is practicing simultaneous equations and quadratics from the problems. And then, if you get a chance to do anything more during the week, remember the key to this algebra is practice, practice, practice. Okay? Have a look ahead at those topics in the Bird book and refresh your memory. If you already would have covered them, certainly would have done on BTEC. Okay? Sine and right angle triangles, so we'll be doing the standard trigonometry for right angle triangles, and a sine and cosine rule as trigonometry for non-right angle triangles. Alright?